Welcome back. Remember we were figuring out the possible sums that you would get if you rolled 2 dice. So we started filling in this table and I stopped right here at 7 because I want you to think about something. When I roll a 7, I could get a 1 and 6, I could get a 2 and 5, a 3 and 4, a 4 and 3, a 5 and 2, or a 6 and 1. But then let's look at the sum of 8. Well, did you write that you could get a sum of 1 and 7 to get 8? It's true that 1 plus 7 is 8, but you can't roll a 7 on a dice that only goes up to 6. So that actually doesn't count as one of our possible sums. Instead, we have to start with 2 and 6 to get 8. So I could roll a 2 and 6. I could roll a 3 and 5. I could roll a 4 and 4. I could roll a 5 and 3, or I could roll a 6 and 2. Same problem here with 9. In order to roll a 1 to get a 9, I'd have to have a 1 and 8, but my dice doesn't go up to 8. Same problem with 2, so I actually have to start with 3 and 6. So to get 9, I could roll a 3 and 6. I could roll a 4 and 5. I could roll a 5 and 4, or I could roll a 6 and 3. So in order to roll a 10 then, I have to start out with a 4 and 6. Or I could roll a 5 and 5, or I could roll a 6 and 4. Notice how our possibilities now are shrinking. To get an 11, I could roll a 5 and 6, or a 6 and 5, and to get a 12, I can roll a 6 and a 6, but those are the only options. So now that I have this chart all filled out, let's figure out how many possible ways I can get these sums. So I noticed that if I want to roll a 2, there's only one way to do it. To get a 3, there are 2 ways to do it. If I want a 4, there are 3 ways to do it. To get a 5, there are 4 ways to do it. 6 has 5 options. 7 has 6 options. But remember, then we started to go down. If I want an 8, there are only 5 options. To get a 9, there are 4 options. 10 has 3 options, 2 options, and then 1 option. So how many options are there total? Well, I can add these numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. And if I add all those together, I will get 36 possible rolls if I have 2 dice. So going back to our theoretical probability, remember we first wanted the theoretical probability that player A wins in game 1. So remember that in game 1, in order for player A to win, he has to roll a 3, 5, 7, 9, or 11. So if we look back at our probabilities, I could roll a 3, 5, 7, 9, or 11. I remember that if I want to get a 3, there are 2 ways I can do it. To get a 5, there are 4 ways I can do it. To get a 7, there are 6 ways to get that. To get a 9, there are 4 ways. And to get an 11, there are 2 ways. So if I add all these together, I get that there are 18 ways for player A to win game 1. So my theoretical probability is that he has 18 out of 36 possible ways to win. Well, if I simplify that fraction down, it's going to simplify down. 18 divided by 6 is 3. 36 divided by 6 is 6. And that simplifies to be 1/2. Well, if there's a 1/2 probability that player A wins, there's also a 1/2 probability that player B wins, which means here in game 1, both players have a 1/2 or 50% chance of winning. So I would say that yes, game 1 is fair, because both players have an equal chance of winning the game. Well, what about game 2? If we look back at game 2, player A wins if the sum is a 5, 6, 7, 8, or 9. So in order for player A to win then, I have to get a 5, 6, 7, 8, or 9. So if I find the sum of those, well, if I want a 5, there are 4 ways I could get it, plus 5 ways to get a 6, plus 6 ways to get a 7, plus 5 ways to get an 8, plus 4 ways that I could get a 9. If I add all of those together, I'm going to get 24. So there are 24 out of 36 ways that player A could win game 2. If I simplify that fraction, I get 1/3. Oh, excuse me, 2/3. Well, if there's 2/3, 2 out of 3 ways that player A could win, that means only 1 out of 3 ways that player B could win. So, player A has a 2 out of 3 chance of winning. Player B only has a 1 out of 3 chance of winning. So I would have to say that no, game 2 is definitely not fair because player A has a much better chance of winning than player B.